Welcome to qnawire.
All right, in this problem we have a scuba tank with a volume of 3,100 cubic centimeters. It's 50% pure oxygen, 50% pure helium by volume, and we assume that the gas is at 20 degrees temperature and has a gauge pressure of 12 atmospheres. We're first asked to find the total number of molecules in the tank, the ratio of average kinetic energy, so the molecules, and the ratio of RMS speeds for the molecules. So to start off, we can use the ideal gas law to find the total number of molecules. This is part A. We can say that PV is equal to NKT. We need to find what K is. We need to find what N is. We already know what K is. N is simply PV over KT. K is the Boltzmann constant. We know it. T, we're given the volume. We're given the pressure, which is the gauge pressure. So plugging in numbers, we would have an atmosphere is about 1 times 10 to the 5 pascals. We multiply by 1/2 because it's exactly half of each species. The volume is 3.1 e to the negative 3 meters cubed once you convert from centimeters to meters. Boltzmann constant is always 1.38, 10 to the negative 23 joules per Kelvin. And the temperature is 293 Kelvin, going from 20 degrees Celsius to Kelvin. So the pressure we get, the number of molecules we get for each species is about 5.048 times 10 to the 23, which is a reasonable order of magnitude. We can expect about 10 to the 23 molecules in normal sized matter under normal conditions. And because we have exactly half of each by volume, we can expect this number of molecules for each one. So it's a 1-to-1 ratio. For part B, so the average kinetic energy of particles in a gas is simply 3/2 kT. Since both species, both the helium and the oxygen, are at the same temperature, T is the same, everything else is the same, so we expect a 1-to-1 ratio in the average kinetic energy. So that part's real simple. The average kinetic energy of molecules is also given by 1/2 mv squared, where the v, the velocity, is the RMS speed. So if we have 1-to-1 ratio, it must be the case that 1/2 the mass of the pure O2 times its RMS speed is equal to 1/2 mass of the helium, He, times its RMS speed squared. Now, if you recall that first you can say this has to be equal to 3/2 kT. From part B. So if we reorganize this to get the ratio of RMS speeds, we end up with, let's see if we can get it in this one page, VRMS over VRMS. If we compare helium to O2, it ends up simply being the ratio of its masses, of the square roots of its masses, which will be root 32 over 4, because O2 has a mass of about 32, and helium is mass about 4 in atomic units, right? This is just root 8, which is about 2.8. And that's it. We would expect the helium to have a root mean square velocity that's about 3 times larger than that of the oxygen, given the situation. And that's it.